All right then. So we're going to look today at converting words in English to, well, words in mathematics or algebra, okay? Algebraic notation. So you have to think a little bit about what you're reading in its English form to be able to convert it and translate it. I think I do want to start with a quick note. There's some key things that you can look for to know, to be able to tell whether you have to add, subtract, multiply, divide, what have you. So let's do this. See note. Let's flip over to the notes page there. Okay. So let's just call this word problem translation. Okay. So how do you know, like when you're reading words, when you need to add something? What kind of words might you see? Yeah, it'll say added to obvious, right? That would be the, kind of blatantly. But you might see words like greater than, right? Greater than. What's that? Yeah. Some. Maybe some other ones. Okay, words like that will tell you when you convert it to algebra, you'll be using a plus sign, right? What about maybe for subtracting?
Difference.
Yep. It'd be difference. What about the opposite of this? Maybe less than, right? Yeah. Or even, subtracted from, obviously, right? Okay. Multiply. Obviously, if you see the word times, right? Like that, okay? What if you see the word twice? Something is twice is what, right? Or 3 times, right? Here's another thing. Almost most of the time when you see the word of, that means to multiply. 5 of them. Maybe you have like pairs of something, right? And 5 of those pairs would be 5 times 2, right? And like that, maybe. Okay? So that's a key a lot of times to multiply. What about to divide? Quotient. All right, you see that word? Huh? Yeah, it's funny. Funny. Like you kids all use like plus, minus, and times as verbs. Like times the 2 numbers, plus them together, minus them, right? But you never, like when you're dividing, why doesn't anybody just say to divide? It's the result of dividing.
What's the result of multiplying? Product?
Product, yeah.
Yeah, I thought.
Yeah. But no one ever says quotient the numbers. Oh. Also, maybe you'll see ratio. Right? That would mean division, wouldn't it?
Okay. That line.
Well, that would be the notation you make. So this is like words that you see that then you might make that line to divide.
Numerator, denominator?
Yeah, you have to see numerator, denominator. I'm not going to...
I know which one's which, though. Numerator's on top,
Yeah.
denominator's on bottom.
Denominator starts with a D, down, maybe. It's down on the bottom. That's how I remember it. When I was 3 years old, I remember it that way.
3?
Up 2. What about half? If you see half, does that mean divide? Right? Or third? Etc. Or fourth or whatever? Stuff like that. Okay? I don't know how many are in this lesson, but for like equals, you might see the word is. Right? Like the product of a number and another number is, right? So you would multiply and then write an equal sign for is. Does that make sense? See that? Okay? All right. Let's go back then and see if we can do some translating. Everybody got this? Again, if you don't get anything, everything, it's on. It'll be on Teams later. Okay. So part A here, write a calculation and a result, right? So it actually equals. That represents a number that is 5 greater than 3. What would we write? Yeah, 5 greater than 3. 5 plus 8. I mean, I would tend to start with 3, but I guess it doesn't matter too much. 5, right? There's 3, and there's 5 greater than it. Okay? And they said they do want the result, so that's obviously 8. Yeah. Part B, write a calculation and a result that represents a number that is 2 less than 9. 9 minus 2. This is going. You guys have done this before. Okay, good. Write a calculation that represents the sum of negative 3 and 8. The sum.
Minus 3.
The sum of, well, okay.
Or negative 3.
That's equivalent, but like straight from the statement here.
Negative 3 parentheses minus 8.
Yeah, I really don't need it there because there's nothing in front of it. Like, technically,
Okay.
yeah. I mean, I wouldn't mind if you did it. That's fine. But what is negative 3 plus 8? If I was doing it this, 8 plus negative 3, then I'd want it, right?
Yeah.
Okay. What is that equal? 5. You weren't wrong when you said 8 minus 3, but it literally says the sum of. But then you could convert it to 8 minus 3, be correct, right? You know, work with it. That's fine. D, calculation represents the difference of 20 and 12. 20 minus 12
Equals 8.
equals 8. E. Now I've got an X in here. If X represents a number, write an expression that represents a number 10 greater than X. Yeah, 10 plus X, right? But I like to start with the X and then show 10 greater, because sometimes, like the algebraic notation is almost like in reverse of the words, kind of like Spanish sometimes, different languages. Yeah. F there, N represents a number. I want a number that is 5 less than N. N, and start with N, and you want 5 less, so you take 5 away, right? Okay? G. Now we have a Y. Write an expression that represents the sum of Y, the sum of Y, and a number 1 greater than Y. Uh-oh.
9 plus plus.
Okay, well, let's think about this. Well, okay. The sum of Y, how do we find a number that's 1 greater than Y?
Just add 1.
Y plus 1. So it's going to be the Y plus that number you just said. So Y plus Y plus 1. Right? That was the first little confusing one, right?
Don't we have to write the results?
No, they
We
didn't.
can't.
Well, we
don't
could.
know what the Y is. Or the-
No, I mean, we could combine it, right? You could just call that 2Y plus 1. Yeah. All right, let's try H. If n's number of right expression represents the difference between a number 1 larger than n and 1 smaller than n.
N plus N minus 1.
Careful. Let's start with the number 1 more than n and 1 less than n. What would the number 1 more than n look like?
N plus 1.
Okay, let me do this. N plus 1
Minus.
represents the difference between. So minus 1 smaller than n.
Minus 1 N.
Okay. But now when we simply, you notice how it's really important, like from yesterday I put a parentheses around this one, okay? Because it wouldn't work right if I didn't. So if I was to like distribute through the 1 here and the negative 1 here, what would I actually have? What? minus n plus 1, right? Effectively, that makes the n's go away, doesn't it? You just end up with what? Which is 2, right? Okay? So that was kind of a weird one. All right. Let's go down here to exercise 2. Well, how about translating verbal statement into expression? All right. And if it's numerical, they want us to evaluate it. Okay? All right, A, or expression for a number that is 5 times greater than 2. Yeah, simple, wasn't it? Well, I don't know.
Times.
5 times greater than 2.
2 times.
Right. So it would be 2 times 5. Of course, that equals 10, because they want us to do it numerical. Okay? B, if n represents a number, write an expression for a number that is twice n.
N times 2.
Yeah. Or we would generally write it 2n, right? You're not wrong, but it's just 2n times things multiply. C, write an expression for the quotient or ratio of 12 and 3. There you go. And it's numerical, so they said so that would be 4, right? And the last one there, write expression for the ratio of x to 5. X over 5. And I hope you're all using these horizontal fraction lines, not the diagonal ones anymore. They're invalid when working with it mathematically. I'll explain that because
He yelled at me for it the other day. Yeah, I know. You can't do
I
that.
didn't yell.
Not yell. You can't do that.
Whenever you look at a kid, you say, don't yell at me. I'll explain it at some point, but make sure you use it. The diagonal ones are more for like final presentation or something. When I put a grade on your test, like if it's 30 points and you get 20, I'll do 25 diagonal slash out of 30, because then we're not doing anything with it after, right? Okay. Next page. More of the same stuff here. So if x represents a number, the right expression for a number that is 3 more than twice the value of x.
X times 2.
Yeah, or 2x. So you see how we, like, I want to, like, the way it's written, in English, 3 more than is first and twice. But then you got to think, I want to start with twice the value of x, right? So 2x plus 3, right? Why don't you guys all take a minute here and just work through these on your own, and let's see what you come up with. So you're forgetting this stuff, okay? You may think about when you might need to use parentheses, right? Like to group something that's supposed to be like one thing, right? Okay? Everybody take a minute or two. How about for B? Anybody have something? What do you got? Say it again? No, not n minus 1/4.
Okay, I have it. N minus n over 4 and parentheses minus 2.
No, not quite. Yeah.
4 n minus 2.
1/4 n minus 2. So you got to think almost like in revert, right? You want 2 less than something. Well, what's the something? 1/4 of n. So it's like you got to start with that. And then 2 less than that would be minus 2, right? Okay. Everybody get C yet? That's, no. 5s minus 4. Anybody have that? Okay. So, right expression, let's see. So,
S.
4 years less than 5 times her age. It could be confusing, can it, right? 4 years less than 5 times her age. So it's 4 less than something. What's the something? 5 times her age. Let's start with that. 5s, then 4 less than that. Minus 4. Start to make sense of that there? In part D, does anyone's expression have parentheses in it? Am I the only one that has parentheses? Hang on.
Oh, I see.
3 times the sum. You get it now?
Yeah.
Okay. You notice how like 3 times the sum of a couple of things? So it means we need to wrap those two things, whatever that is, in some duct tape or something, all right? And then multiply it by 3. Does that help you think about it? Okay. What do you have? What do you think? Yeah, 3. That's what you had? X plus 10. When stuff's in parentheses like that, guys, the way you like some of you will read it 3 parentheses, but what you could say is 3 times the quantity x plus 10. You could use that word, and when you say the quantity x plus 10, then you kind of know you're using parentheses. Is that what you had?
Yeah, but I can't read it because I didn't see.
Okay, well, that's a separate problem. How about E? What'd you get? I couldn't hear you. 5n minus 7. Ends on 7 less than 4 times the difference of n and 5.
7 minus 5.
So what should we start with? We should start with the difference of n minus 5 because these are the things we're doing to it. Does that make sense? So let's start with n minus 5. Does it sound like it's its own like quantity going to be worked on here? It's going to be 7 less than 4 times all of this. Okay. Now what should we put in there?
4.
4 times that difference.
Negative 7.
And then 7 less than all of that. Right? Okay. So now maybe we're thinking a little more clearly. I'll give you guys another couple minutes to work through the rest of these here. See if you can. Yeah, you could, right? But remember, you're using that horizontal fraction line, that x is parentheses, right? So x minus 3 over x plus 2. Does that sound good, you guys?
Yeah.
The ratio, so we got that division in there. Yeah. What'd you get for G? What's this one? I can't see. Say the number. Or what? Huh? Which one is this one? Oh, F. How did it sit, Leonard? Oh, I see more else. Get my eye on you. Somebody else want to take a stab at G?
2x.
Come on. 2x.
2x. Sum.
Plus.
Plus.
Yeah.
X plus 1.
Oh, almost.
1 plus x.
Let's see. Right expression for the sum of twice x. There's my twice x with twice a number that's 1 larger than x.
Oh.
So
That's 2x plus 1?
what's how do we get a number 1 larger than x? And how do we get twice that? Yeah. You're close. Try. Try number 8 or letter H. There's a couple ways to do. No, not H. Scratch it. I was looking wrong. Let's continue on with the abuse then. And please provide me the abusive answer for H. 2n over the whole n minus quantity, right? You guys get that? 2n over n minus 3, okay? The quotient, so we got to have dividing in there, of twice n, there's my twice n, 2n, with 3 less than x, n minus 3, okay? Take a look at I. Well, say it. Say what you got. Don't be scared. Yeah. Yeah. I would have led with the 3/4, but it doesn't matter, right? 3/4 of the difference of y and 8. Well, we know we're going to do something to the y minus 8, right? So I want to do that. And then 3/4 of it. Right? All right, last one. 2 ways to do this one.
Wait, can I
What are you asking me for? All right, good talk. You got it?
I have it.
Yeah. One half times quantity x plus 4.
That's what
Yeah.
I had.
Okay, there you go. Also, what else could you have written? Or we talked about. No, not
X
over.
plus 1 over 2?
X plus 4 over
Or
2.
that's what I meant.
Yeah. This is also the same. Okay? It's equivalent to that. We're going to skip exercise 4 for now. Okay? What I do want to go, remember I said there's one problem from 1.11 I want to bring in here. Okay? So what I want you to do is go to page 74. Go to, you might want to note this in your book here. Page 74, number 4. Okay? Page 74, number 4. Which is right here. This is the one, because these are kind of like common things in the algebra region. So let's take a look at number 4. The length of a rectangle is 2 less than 3 times some number x. Okay? And the width, maybe we should take these one at a time, huh? And the width is 5 more than that same number x. Okay? So it wants to draw a diagram and label it with what they just said. So well, let's do the hard part. Let's make a rectangle. The rest of this will be easy, right? Okay. And it really doesn't matter what you call length and width, whatever. So we got this here, 2 less than. That means we're subtracting from something. There we go, right? So 3 times the number, it would be 3x minus 2, right? And by the way, it's a rectangle. Both sides are, the sides are congruent. So wouldn't this also be that? Okay. Well, let's handle the other side here. This, not so bad. 5 more than that same number x.
3x minus 2 plus 5.
Oh, no. See, that's confusing. Then the same number x. So it's much simpler. 5 more than means to multiply. X plus 5. And this would be x plus 5. Everybody with me on that? Okay. And now the follow-up here. So this is just like the stuff we were doing on the previous page, right? You notice here, 2 less than something, right? So we want to start with the something. What's that? 3 times the number. There it is. And then 2 less, okay? Okay. There's our diagram. Use the diagram to find the perimeter of the rectangle in terms of x. Guys, how do you find perimeter? Add up all sides, right? So before we write anything down, what would you say our perimeter equals in this diagram? Three x minus 2 plus 3x minus 2 plus x minus 5 plus x minus 5, right?
Not x plus 5.
plus 5. Plus 5, yes, okay. Is there a shorter way to write that out since both pairs of sides are equal and there's 2 of them?
Times them by 2.
What them by 2? Is that, what'd you say? What them by 2? Multiply them by 2, that's what she said there, right? Okay.
Yeah.
This times is not a verb. Well, it would be 2 of these, right? 2 times 3x minus 2 plus what? 2, well, 2 of them, right?
2 and then x.
Yeah, okay. So what I want you guys to do now is go ahead and distribute through and simplify all of that, right? So your next line will be perimeter equals, okay? So we're going to take a minute, distribute the 2 here and distribute the other 2, okay? Well, it turns out it is 8x plus 6. Let's distribute through. 2 times 3x is 6x minus 4 plus 2x plus 10, right? Combine like terms. 6x and 2x is 8x. Negative 4 plus 10 plus 6. That's your perimeter.
How'd you get negative 6?
Maybe
That's the 10.
I did negative 4 plus 10 and I got.
Just a
I did them all.
slight little error. Okay. Now, let's take that same rectangle and find the area. How do you get the area of the rectangle? Yeah, or base times height, isn't that right? Better think of it as base times height, because you get to geometry, everything's in base and height. So
We get to geometry?
when you do, yeah, next year. Well, presuming you pass it. What's the area of the rectangle? Okay, well, what's the length and width up there? Those 2 things. So we're multiplying. So area will equal what? Somebody tell me. Yep. You just multiply those guys, right? And we've been doing that, right? So you know what you're going to do now, right? You're going to distribute twice, combine like terms. Okay? So everyone do that right now. Distribute twice, combine like terms. Equals, right? Again, you guys see how my algebra looks, right? Like up here, I got perimeter equals all the way down, area equals. So distribute 3x squared plus 15x, right? Now distribute the negative 2.
Negative 2x.
Minus 2x minus 10. Right? Because negative 2 times 5 is negative 10, right? So 3
X
squared
plus 13x minus 10.
minus 10. There we go. Okay? Anybody have any questions on this? Okay. All right. Well, there's a side problem set there for 1.10. But, let's see here.